you out of the shower yet, Pong? Your tea is almost ready. We've got lots to do today. Oh! Oh! Pong, what's happening? I think we need to reboot the generator.
Yes, Captain Buster. A reboot has already been initialised. Reboot complete. All systems operational. Energy levels are now at maximum.
Phew, that's better.
You know why this has happened, Buster? You've been using way too much energy. You need to find ways to save energy.
I think you might be right, Poogle.
Buster, you've just been sent a new mission. It's all about renewable energy and it might give you some ideas.
Renewable energy? That does sound interesting. Download the mission brief, Poogle, and let's get started.
Of course, Buster. Download complete. Humans use electricity to power nearly everything. They use so much electricity they have to get it from a variety of sources because no one source can supply enough. Humans get energy from natural gas, oil and coal, which are fossil fuels, nuclear power and renewable energy sources, which come from things like the wind, the sun and the sea. Your mission is to investigate wind power, which is a renewable form of energy. Wind is one of many types of renewable energy, generated from a natural resource that can never be used up.
I know you never run out of wind, Pong.
Humans have used wind energy for a very long time. The first windmills were built over 5,000 years ago. Today, wind energy is also used to generate electricity.
Wow, that is clever. How much electricity is made from wind power then?
Well, Buster, did you know the UK is the windiest country in Europe? This makes it the perfect place to capture wind energy. There are over 1,000 wind farms with nearly 7,000 wind turbines, which create enough electricity to power 8 million homes. That's 11% of the UK's overall energy, which means wind is a very important source of power for the UK.
OK, Poogle, that's a lot of wind farms. But what exactly is a wind farm? Is it a place where animals like Pong live together and have really bad wind?
Not quite, Buster. When wind turbines are grouped together in one place, it's called a wind farm. Wind farms can be built on land, these are called onshore wind farms, or out at sea, these are called offshore wind farms. When deciding where to put a wind farm, there are lots of things humans have to think about. They have to be positioned carefully so they can capture the most amount of wind. Humans also try to make sure they have as little impact as possible on the countryside.
So, Poogle, just how tall is a wind turbine?
Well, wind turbines come in different sizes, but usually about 80 metres high. That's as high as 18 double-decker buses. And the blades can sweep a circle in the sky as long as a football field.
Wow, that's so tall. Why are they so tall, Poogle?
Well, on planet Earth, the higher up you go, the windier it is. And more wind means more electricity can be made.
Why are they all the same colour? Why can't they be bright blue like me?
Well, most wind turbines are painted light grey. This helps them blend into the skyline.
Is a wind farm noisy?
Well, on Earth, they measure sound in something called decibels. A normal car is about 100 decibels. Whispering is about 40 decibels. And a wind farm will have a sound level of about 35 to 45 decibels. So, if you stood about 3 football pitches away, a wind farm would have the sound level of leaves rustling in a breeze.
OK, but I still don't understand how a turbine turns the wind into energy.
OK, Buster, you might need your notebook for this then.
Ha! Yeah. Right, we're ready. Our brains are engaged and we're ready for some science!
So the blades catch the wind. Each blade of the wind turbine is angled in a special way, like an aeroplane's wings. A force known as lift is generated on one side and the blades start to spin round. A sensor is used to make sure the turbine keeps pointing into the wind. The blades turn the rotor. Each turn of the rotor is called a revolution. The rotor turns a shaft that is connected to a set of cogs called a gearbox. The gearbox is connected to a generator which makes electricity when it turns. The gearbox is like gears on a bike. It makes the generator spin fast, even when the turbine blades are spinning slowly. The generator uses an electromagnetic field to change the mechanical energy into electrical energy. The electrical energy then travels along cables down the tower to a substation. Here it's converted to a high voltage before being delivered to the national grid.
The blades are connected to the rotor's connected to the gearbox connected to the generator, and that makes electricity.
Very clever, Buster.
But wait a minute. What happens if there isn't any wind?
Well, wind turbines start operating when there is only a light breeze. Would you like me to demonstrate this using the wind simulator?
Wind simulator? Huh, yes, please.
Stand by for turbine simulation.
Right, Poogle, let's go.
Simulation activated.
Oh, that's really not very much wind, is it?
Wind turbines reach maximum power output when there is a moderate breeze.
Oh, okay, so this is a bit more windy.
Sometimes a wind turbine stops moving, but often this is actually because there is too much wind.
Whoa! I think we better stop the wind, Poogle. Abort turbine simulation.
Simulation terminated.
Oh, are you all right, Pong? I think that was way too much wind, Poogle. I can see why turbines would have to protect themselves from damage in gales. I think Pong does too.
Wind power is a low-carbon energy source because wind turbines don't need any fuel. They are also clean and friendly to the environment.
Can we see an offshore wind farm now, please, Poogle?
Of course, Buster. This is an offshore wind farm. Winds at sea are often more frequent and more powerful, which means they can make more energy. However, building wind turbines in the sea is expensive, as the turbines have to be built to withstand rough weather conditions, and building at sea means humans have to take even more safety measures. Also, even at sea, they have to be careful not to disturb the wildlife and birds, and must make sure they don't get in the way of the shipping lanes and fishing areas.
But I don't understand, Poogle. If the wind turbines are out at sea, how does the electricity get back to the land?
The electricity is sent down thick cables which run down the tower to the seabed and across it to the land.
Thank you, Poogle. I think we've got everything we need to file our wind energy report to the Intergalactic Federation's Renewable Energy Department.
Yes, Buster, I think you do. So what are the advantages? Well, wind is a renewable energy resource, so it will never run out. There are no fuel costs and no harmful polluting gases are produced. It's a low carbon energy source. And the disadvantages? The amount of electricity generated depends on the strength of the wind. If there is no wind or too much wind, the turbines don't create electricity. Turbines can be seen from far away because they are so tall. Wind farms make a noise that can be heard when you are near them. Although wind power offers an important energy source that has minimal environmental impact, it's not possible for it to provide all the energy humans demand on its own.
But less would be needed if humans wasted less energy. They can do this by using it more efficiently, like remembering to switch off lights when they leave a room and stuff like that.
Exactly, Buster.
Oh, looks like the investigation has given Pong an idea for another energy source. Perhaps you could power our ship, Pong.
Good idea, Pong. There's just one small problem. There's no wind in space.